Hi everyone, I'm Laura, head of social here at CareerFoundry. Welcome to this live event with Dr. Humera. In case you don't already know, Humera is a teacher at heart, a data scientist by profession, and an entrepreneur by mindset. She's a machine learning expert and also a CareerFoundry mentor. While people are joining, please drop your name, where you're joining from, and why you're interested in a career change into data analytics. We would really love to know. You can drop that in the right hand side in the chat. And before we kick off, let me briefly introduce you to CareerFoundry. To those of you who don't know, CareerFoundry is the online school for your career change into tech, providing personalized programs in data analytics, UX, UI, digital marketing, and just very recently, product management as well. The CareerFoundry Change program takes you all the way from complete beginner to job-ready tech professional with one-on-one access to both a mentor and a tutor, which is super useful, as all of those of you who are transitioning into a new career field should know. The mentor and tutor are both experts working in your new field who will guide you to success in finding a job and preparing for the job interviews. And that's not all. CareerFoundry programs are 100% online and flexible, which means you don't even need to quit your job to do them. So they're backed by your job guarantee as well. So if you don't land a job in your new field within 6 months of completing the program, you get your tuition refunded. And with that, let's kick off this amazing webinar. Dr. Humera, thank you so much for being here. The floor is yours.
Thank you very much, Laura, and hello, everyone. Again, this is Dr. Humera, and I'm a data engineer, data scientist by profession, and a mentor at heart. And I love sharing my knowledge with everyone who would like to jump into the field. And today, I want to introduce you to data analytics. My personal journey with data analytics, data science, and machine learning has been for over 20 years now, and it never gets old. I once, when I actually joined into this field, I got this advice: hey, pick up a field which is going to stay. And at that time, I picked up machine learning, and it's still true. This is a field which is here to stay, and I want to really welcome you to this career path if you want to take it up and want to clear up some doubts, give you some overview to what data analytics is about and how you can get started. So, without further ado, I'll actually take you straight into what data analytics is and how does it look like. So, data analytics, as you can see here, is not one thing. It's a collection of multiple things, but we can divide it roughly into 5 steps. And it starts with, actually, I like to add a 0th step here as well, which is when you decide that you want to do data analysis. And this is where you identify a problem and you say, I have a problem and I may need data analytics to solve that problem. So that recognition of problem is the first step or the 0th step that says, okay, I want to go into this field. So what would be that 0th step where you say, where do I apply data analysis? Before knowing how you apply it, you need to know where you apply it. And actually, wherever there is data, you need to analyze that data. And this is where data analysis comes in. And where do you have data? Any guesses on if you as a common person gets in touch with data on your day-to-day life, day-to-day business, or is it something which is only for tech-savvy people? So any ideas on, do you use data in your day-to-day life? Feel free to put your answers in the chat and I'll be happy to see what you are sharing. But while you do so, I'll proceed from here. Um, it doesn't matter if you are a tech savvy person or a non-tech savvy person. It doesn't matter even if you use a computer or not, because data is everywhere around us. Like, you look at the weather, is it going to be a rainy weather today or a sunny weather today? This fact that a date and a temperature and the percentage of chances of rain is connected to each other, that's a data point. whenever you are using Google to search for anything, any search query that you do, that's when you are creating a data point. And whenever you look at your navigation to check how do I reach from location A to location B, you are consuming data. So you are, be it when you go to whenever it's like about healthcare, where you are giving or taking up some medical information, or is it browsing the web, or is it checking out the football scores of the recent match, checking out the Bitcoin prices, checking out the flower prices for gifting it to somebody. Like you name it, you are either producing data or you are collecting data. And whenever there is data, you need to analyze that, and this is where data analysis comes in. Today, we are going to look at one such application. You have it already with you as well, the food delivery system, and we'll see that how once you have decided that, okay, you need to work on data, we'll see how you work on it. But let me give you an overview to how this pipeline looks like. So let's say now you are at a point where you say, okay, I have this problem. Let's say I want to forecast tomorrow's weather or next week's Bitcoin prices. Uh, how do I start? So, this is where you start first. You start collecting data. And data collection is the first step because you need to have data to work further on it. And let me give you the whole pipeline quickly and then we'll go into the details. So now you have collected the data. You can collect this data by yourself by putting sensors out there, or you can even download data. There are a lot of resources. But once that data is there, you need to often clean it up because the real world is messy and the real world data is also not always very clean. I can give you a few examples. So maybe there are missing values. Maybe you sent out a survey form and there were some entries where people didn't put anything, so you got a blank result, so there might be missing values. Or maybe you are collecting data from sensor and it didn't send any data points for a few seconds and you got those values as missing. So there could be a number of reasons why data could be corrupted. For example, missing values. It's also possible that you have duplicates in the data because you might have multiple collection points and some data points might be repeated. Uh, then it could be that there is a problem in formatting of data points. So, for example, date is a very common example. Different parts of the world, different countries in the world use different formats for noting down the same date. And you need to make sure that you are understanding each and every data point in the same way. There is a difference in units, like some people measure weights in kg, some measure them in pounds, and you want to make sure that they are in the same unit. So there could be a number of reasons why you need to clean up the data before you proceed. And then you move towards some more descriptive analysis. This is also part of cleanup, but can be separated as well because this is uh, the kind of analysis that you are doing helps you in cleaning up the data. So, for example, you try to see if there is any outlier in the data. If you have, let's say, you are measuring heights of people and it's somewhere between 5 and 6 feet, and all of a sudden you notice a height of 22 feet, that information might tell you that, hey, having a 22 feet tall person doesn't seem right. Maybe there was a typo or some mistake. So this kind of, again, you need to clean up, but this kind of analysis can be done to get some insights into your data and also to use it for further cleanup. And once you have more clean data, you have some initial impressions of the data, then you move towards exploratory analysis. And this is where you actually really focus on the problem that you are trying to solve, like all this effort that you have done so far. Why were you doing that? And this is where you try to get information out of the data. And for that, you need to ask questions and get answers. And we'll have a look at what kind of questions should be asked and how you generate answers. And once you have them, then you need to do some visualization and storytelling, because this is the point where you have done all the technical work, and we'll just see in a few minutes that how not technical it is. But you have done all the work, and now you need to present it in a way so that your audience can actually make take action on it. It makes sense to people who are not technical people. So, for example, if you are working on healthcare and you are doing some data analysis for some medical professionals, they don't know what data analysis is, they don't know anything about data, what you know. You would like to present those results in such a way so that they understand that, and you convince them into taking certain action through your visualization and storytelling skills. So enough of theory now. Let's dive deeper into the pipeline, and I'll take you through these steps one step at a time. We'll start collecting data and we'll start working on it. So, as I said, the first step is getting the data. And where can you get the data from? Of course, for your given problem, you will have separate sources to get data. But if you are very new to data analysis, and you want to find out where do I start, where do I really get this data from, then we have a few resources. Laura, maybe you can share this link, which is a CareerFoundry blog, which says, I am about to share my screen so that you can see this. 10 great places to find free data sets for your next project. So if you have no idea where to start with, you simply have a concept that, okay, I want to work on sports. Then come here and you'll see how you can actually find out. I'll increase the screen size so that you can see how you can actually find data sets. As you can see here, you can actually go to Google to search for dataset, go to Google dataset search and search for sports datasets, and it will give you datasets related to sports. Or Kaggle is a very nice portal of data scientists, and there you can actually find, again, go and search for topics of your choice, and you can find data sets like job trends or coffee shops and etc. Then there are more specific websites which give you, for example, government related data. If you want to go for, let's say, geographical earth related data specifically, then we have earth data related portals. So you can visit any of them and you can actually get data sets. For our exercise today, now this is the second link that Laura, maybe you can share, is, and actually all of you have it already, is this Kaggle Kaggle website from which we have downloaded the data. You have the data set already, but you can go there and you can actually search for whatever type of data sets that you want, and you'll be good to go. So what we are going to do right now is follow the process, and we collect the data that we are going to work on. So as I said, you have the data set already with you. And if not, we can download it and I'll show it to you. So we come here. This is our food delivery system. And so that was our requirement phase 0. I want to work on a food delivery app, and let's say how and what information I get there. So I come here, I download the data. So it gets downloaded, and it's here called archive.zip. I'll go and unzip this. So now it's unzipped and it's on my computer. Next step, now that I have the data, I want to start working on it. So I can use any of the existing tools to import the data or open the file that I have just received. So you can use any of the tools that are out there. If you have, for example, Microsoft Excel, you can open the data set over there. If you have Google account, then you can go to Google Sheets and work on that. you just need a spreadsheet on which you can open your data set. We are using Google Sheets today because I like it, because it's free, it's online, it's on the web. You don't have to download or install anything if you have an account, and most of us do have a Google account. And if not, it's easy to create an account. And that's why I really like to use Google Sheets to get started. And for our purposes, it works. So now enough of theory, let's go and import our data set. Now I'm sharing my screen again. So let's say I open a new tab and I go to Google Sheets. So as I said, if you have Google account, you will see yourself there. If you don't have a Google account, when you will come to this page, it will show you a pop-up and ask you to create an account, and you can actually create a new account. I already have one, so I don't need to create one. Once you have an account, you go to the Google Apps on the top left corner, top right corner, and you scroll a little bit to find and open Sheets. This is Google app for Sheets, and you create a blank sheet first. And here you can import the data that you have just downloaded. So I go to File, and I either say Open or Import. And this is on my computer. So on my computer, or on the uploads menu, I can browse, and I just downloaded this food delivery app, so I'll open this. So it's opening, and yes, it's open now. So as you can see here, let's have a look at this data, and you can actually get more information about it, and you can also work on it. There is one more way to open files, and that's not by using open, rather by doing import. And let's have a look at that as well. So you can also, like before, open a new tab, go to Apps, Sheets, create a new worksheet. And this time, after going to File, instead of going to Open, you can also go to Import. And it will show you the similar menu. You can upload a file, select a file, food delivery, open. And it asks you if you want to open it right here or in a new sheet. You just open it right here, and it's right there. So you can use either of the two ways to open your file, using open menu or importing. So let's keep it like this. Right now it's untitled spreadsheet. You can give it a name, let's say food delivery. Having a quick look on how does our data look like. Let me quickly check if you see my, yes, you see my slides. Here we see that there is name, age, number of orders in a month, effect of COVID-19 on food ordering habits, average order value, payment system, average delivery time, and average delivery fee charged. So these are the 8-10 parameters that are being checked, and how many data points do we have? So each row is representing one data point. And if I scroll below, then I see 446, and the first row is the header row. So we see 445 data points. So this is how our data looks like. And this is actually our first step. So we have actually found data and imported it. Now let's move towards our second step, which is cleaning the data. So cleaning, we just spoke about it. Cleaning might include removing of duplicates, removing of missing values, changing data format, etc. So let's try to have a look at our data set and see what kind of cleanup do we need to do. How do we do cleanup? It's very easy because of the tools, and actually our tools help us in cleaning up the data. What we can do here is, for example, simply go to data and go to data cleanup, and here is remove duplicates. So let's click on this. It asks you to select a range of cells containing values. This is important because what do you want to check to clean up duplicates? Do you want to clean up duplicates in only one column, in only one row, or you want to do it for the whole data? So it's very important that you select the data that you want to use for cleaning up and then proceed. So now by clicking on the top left box, we have selected all the rows and all the columns. Then you go to data, data cleanup, and remove duplicates. It asks you if your data has any header row, and yes, we have a header row, so we pick that. And then, so now you see it has all the names here, and then you click remove duplicates, and it says it checked, and there were 2 duplicate rows which were found and removed. And this is already very simple. It makes our life easy because imagine if we have a lot of duplicate data, then our data is not representing the right information because it's simply duplicating. We thought we had 446 rows, but we in fact had only 444 rows. Okay, this was already a very clean data set, so only 2 duplicates were there. But imagine if there were hundreds of duplicates in your data set, then your statistics would be very wrong if you would not have cleaned the data. So this was one of the first steps, how you could simply clean your data. And there are now other ways to clean up information as well. And as you just saw, when we scrolled below, there were a lot of empty rows in the bottom. It's also possible, as we spoke about earlier, that there might be missing values while we were collecting data as well, and we may want to remove those values as well. So how you can identify where are the missing values and how you can remove those rows? For that, we can create a filter, and we can use that filter to filter out certain values. So for example, how you do that? Again, you select the whole data, and then you go to data, and you create a filter. What filter does, by doing this, as you can see on the top of each column, there is now a filter like symbol. And let's say I want to check the column D and say whatever empty rows are there or empty cells are there, just I want to check them first. So you click on that, and then you say, what do you want? First of all, clear all previous filters. I only want to see blanks here. So I click here and then I click OK. And now I only see that one row where this column was blank. So in this way, you can actually filter out your data points which has a certain value. And I may want to delete this value, delete this row. There are a lot of things that you can do with buggy data, like you try to replace that data point, but to keep things simple, we are deleting them. And then I go back, I select everything. So now everything that I had removed comes back, and I have my data back. And now I have one data point less. So you should be very careful when you are deleting the data points, because you might be deleting half of your data or majority of your data just because there was some problem in one of the parameters. So yeah, we did that today right now to make things fast, but always think twice before deleting data or throwing away data points. What else do we want to do? Let's say we have this age here. We have number of orders in a month. This makes sense. It's a numerical value which shows that, okay, some people place 3 orders, 4 orders, 8 orders, 2 orders in a month. And this was their effect of COVID and average value. Now, let's do something here. I don't want ranges here, let's say. And let me also delete this data point because it has a missing value. I delete this. Let's say I do not want alphabets in here because I want numeric data. I want to do something where I can apply maths on this order value. So again, I'm still cleaning up my data and I'm not happy with this being a range. I want it to be absolute numbers. So what I can do here is do some manual find replace kind of thing, that I look at this column, and wherever there is below 300, I just replace it with 300. So I actually want to do this. And wherever there is 300 to 600, I want to replace it with 600. So just randomly, I'm replacing it with the top value of that column. And why am I doing that? Because I want to apply some mathematical operations, like I want to check a maximum or a minimum or an average of this column. And if I have ranges, then I'm not able to do that. So to solve this problem, I am actually, I want to replace this. I hope that's clear. So now let's do that. I have selected this, and what do we want to do? We want to replace certain phrases with certain other things. So I've selected this column, and I'll go to edit, and I'll go to find and replace. And what do I want to find? I want to find below 300, and with what do I want to replace? I want to replace it with 300. And I'll just do this, and then I'll say replace all. So it happened 73 times that it was below 300 was found and it was replaced with 300. So good. I can see it here as well. And let's say the next one is 300 to 600, and I want to replace all of them with 600. So I do the same, find 300 to 600 and replace this with 600. You can of course say that, no, I don't want to replace 300 to 600 with 600. You may say, I want to replace it with an average. So 300 to 600, the average is 450. So you can say, I want to replace it with 450 only. Or I want to count how many times 300 occurs. Okay, you cannot count that because you don't know how many times the bill was actually closer to 300 or 600. Then these are the few things that you can do. And you need to make that call. So there were 183 instances of 300 to 600, and we replaced that with 600. And then let's say there are 600 to 900, and we want to replace that. And let me do that quickly. So we do that with 900, and then there is 900 to 1200, and we want to replace that, find and replace this with 1200, and replace all, and done. And is there any 600 to 900? It's left. Why? What happened here? 600 to 900, file, no, edit, find, replace. 600 to 900, replace it with 900, replace all, done. And is there anything else? 1200 to 1500, let's take this, select all, edit, find and replace, select this and replace with 1500, and done. No, not done. You had to confirm that. That was the mistake I did previously as well. 1500 and replace all. Okay, and what else? Is there anything else like 1500 plus? I don't see anything like that. So apparently we are good. So I'm happy with the cleanup that I have done. Let's move to the next step. And what else? So now we have some time for descriptive analysis. And descriptive analysis means I want to find out some common mathematical values of my data, like mean of certain thing, average or minimum or maximum, and I want to sort my data and see what this tells me. So let's do this. And how and what do I want to do here is I want to find out, let's say, some information about number of orders in a month. So this is an interesting parameter for me. So let's do that. So I don't want to disturb this sheet. What I'll do is I'll add a new sheet. So click on the plus sign in the bottom left of the screen, and you can add a sheet. And it's always a nice idea to give some representative name to your sheets. So this is the descriptive analysis. So I give it a name, and let me call my sheet 1 also as data. So a representative name. And what do I want to do here? Let's give some headings and some labels. So I am working on the number of orders. So this is the statistical information that I want to do. And what do I want to calculate? So let's say I want to calculate the average. So what is the average number of orders that my clients are placing? And let's say I also want to check what's the maximum number of orders that somebody is placing, what's the minimum number of orders that somebody is placing. So let's see how we do this and what does it tell us. So let's do this. You can actually calculate these values by typing a simple formula into Google Sheets. And to do that, you start by typing equal to, and you start by typing what do you want to calculate, which is average. So you start AVER average, and it gives you an autocomplete. You can hit enter and proceed. Now it opens a bracket. So in brackets, you need to tell the data for which you want to get average. So sometimes the data is right there on the same sheet, sometimes it's not. So this time it's not. So let's go and select the data. Again, you start typing the formula by typing equal to, and then you type what do you want to get out of this. So you want to calculate average. And now in brackets, you need to specify average of what. So average of, you go to data, and you'll notice as soon as I'll click here, it actually brought me to that sheet. And now I want to select column C because I want to get the average of the whole column C, which is I want to get an average of the number of orders in a month. So as soon as I clicked on it, you can see that it said data and then C colon C. So it means it's picking the whole column. And then afterwards, I can close the bracket and hit enter. And when I hit enter, it comes back to the sheet and it gives me the average of the column C. And you can see it here. Let go to data sheet and give me the average of column C. Let's do this again for maximum. And I can see here that the average number of orders placed by our clients is 4.86 orders in a month. And now same for calculating maximum. So equal to, and then you say max, and then you hit bracket, and now you go to the data sheet. So data, and then you pick column C, and then you close the bracket and you hit enter. So now it tells you the maximum number of orders placed by our clients in a month was 10. Looks good. Okay. And now coming to the third one, it's suggesting something to autofill. Let's ignore it for the time being. I continue with equal to, and I want to calculate minimum. The Google Sheet is suggesting to calculate the minimum of these two cells, but we don't want to calculate this minimum of these two cells. Rather, we want to calculate the minimum of column C in data. So let's complete that. Min, bracket open, go to data, select column C, close bracket, and hit enter. And 0. Okay, this doesn't look right. Why do we have an entry which has 0 orders? Let's find at least those entries where we have 0 orders. And how can I do that? Actually, is there a way I can only look at zeros in this column? If you said, yeah, filter, then you are right, because we have a filter. We can come here and we can say clear everything else, and I only want to see zeros. And then you click OK, and now it will show you all the zeros that are in my sheet. And now I can decide what do I want to do, and for the sake of time, I'll delete them. We can do a lot of other things, like finding out the average of number of orders and replace. We already know it, and we can replace that with average. But for the sake of time, we'll just select these rows. How do you select these rows? By clicking on the labels here, you can select all of them, and then right click on the this bar, and then you right click on this, and this you say delete selected rows, and it deleted them, and now there is nothing which satisfies the filter. So now there is nothing that you see. You go back to the filter and you select all the values back again, and now you see everything. And just to be sure, if everything is as expected and there are no more zeros, we can just quickly sort our data and see if it still makes sense. So I select the data, the whole data. So from by clicking on the top left, this empty box, go to data and sort range and go to advanced range sorting options. And data has a header row because yes, we have this header row. And do we want to sort in ascending order like 1, 2, 3, 4, 5, or do we want to sort in descending order 10, 9, 8, 7, 6? You can decide. Let's take ascending order A to Z. I sorted. So what it did was uh, it I said sort it according to name, so it sorted according to name. So let's do it again. Go to data, sort range, advanced range options. Data has a column. We want to sort according to number of orders in a month. We do that and we hit sort, and now you see like ones and then twos and then threes and fours and so on. So and now we come back to our descriptive analysis and we see that now the minimum is 1 and our average has increased as well, and this makes much more sense. So you saw that by just doing a descriptive analysis you are able to, number one, get some idea about your data, and number two, also clean it up. And it's important to know that this cleanup process and this whole data analysis pipeline is very iterative. You often need to have to go back and repeat some previous steps and then come back and then go back and come back. So, and that's perfectly normal. And now I come back to the slides and let's see what do we do after we have descriptive analysis done. So now we can move towards our exploratory analysis. And here it's important to ask the right questions. And these questions depend on your audience. What I mean by this is, if we are talking to marketing team, they might be interested in knowing a totally different thing compared to if I'm talking to the tech team or the business team, the sales team, or the finance team, because for each one of them, their domain is different, their focus is different. So when you start exploratory analysis, you need to identify who you are talking to. Actually, even before you started this whole exercise, you needed to know who you are talking to. And as I said, if you are talking to marketing or sales or business or tech, your questions change. To keep it simple, let's talk about, let's say we are talking to the marketing team. And let's say their question is, which age groups should we target for marketing? So that's their question. They want to do a marketing campaign. Let's say they need to roll out a loyalty program and they are asking which age group should we target? And they came up with this question that by looking at the data, what do you say? So this is our major question. Which age groups should we target? Now we ask ourselves some more questions related to age group. First of all, do we have a trend in age group? How do we know how many people of different age groups are there? Do we know what are their ordering habits? So it means, can we connect age group with order, number of orders? What are their spending habits? Can we connect age group with the amount paid for transactions? So can we link these things together? So why are you asking everything about age group? Because the marketing team wants to know everything related to age group. And this is actually important. So let's try to do that. And I repeat, what are we trying to do? The marketing team asked us, who should we market to? And now we are trying to say, let's first try to find out who our audience is, who our age, what our age group brackets are. So let's go and try to find out if there is any trend in our age group bracket or not. So let's go there and try that out. And how do we do that? How do we identify these trends? And the answer to this is we do this by a tool called as pivot table. And how do we create pivot table? And let's see actually. So I select my data and then I go to insert and I say insert a pivot table and insert it in a new sheet. I'll explain in a bit. Actually, let's see it as we do it. What does it do? What do we want to get here? We want to see if there is any trend here. How many times 18 to 30 occurs in this table? How many times people from 40 to 50 age bracket placed an order? How many times, and so on and so forth. So, what am I trying to do here? I want to count how many times 18 to 30 came here, how many times other age brackets came here. And how do I do that? This is where pivot table helps. Pivot table has rows, it has columns, and it has individual cells. And we can pick and choose what do we want as rows, columns, and cells. So as I have said this several times, we want to check age. So our rows, we want to have age as rows. So you can add rows. And what do we want to add as rows? Age. And so as soon as I picked row's age, it actually gave me all the possible values that it found in age bracket. And what do I want to fill here? I want to count how many times actually people placed order. Now there are two kinds of counts. One is I put as value here age. What is this telling me? And why is this blank coming up over here? We need to clean up our data a little bit more. So let's see, why do we have 0 in age bracket? Are there some blank? Oh yes, why are there blank rows here? And I don't want to count them. And this is again why cleanup of data for these missing values is important. Right now I know all those missing values are at the bottom of the table. So I'll simply select all of them at the bottom of the table and I'll simply delete them. So I am selecting them. I've selected all of them. I'm right clicking and deleting the blank rows because I don't want that blank. And see, as soon as I deleted that, it's gone from here. So, okay, now I'm a bit happier with the data. What is this telling us? This is telling us that 18 to 30 occurred 291 times in this column. So in this column, 18 to 30 occurred 291 times. 30 to 40 occurred 42 times. 40 to 50 occurred this many times. Okay, so from looking at this, 18 to 30 is the age group which is placing the orders with most frequency. What does that mean? I want to also know that when the people in 18 to 30 age bracket, they placed order, how many orders did they place in a month? Because it's possible that these people, these 291 people, are actually placing order only 1 or 2 times, and maybe these people, above 50 people, they are placing order 10 times in a month. So this will change our average. So let's create another pivot table, but this time I don't want to see only age with count of age. Rather, I also want to see age versus number of orders that they have placed. So I go back to data. I selected my data because to create a pivot table, you need to select the data and then you go to insert and then you insert a pivot table in a new sheet. I create a new one, and like before, my rows, I want to still see the age bracket, and in the column, I want to see number of orders placed by each group. So for columns, I want to have number of orders in a month. what did I do here? Sorry, I didn't want to create columns. I wanted to have values of number of orders in a month. And this is right, I don't want to just count, because if I would have counted just every order as one, then I would have received the same count. But I actually want to check some. And now here I see, actually, my assumption was wrong, that people above 50 are placing maybe more orders. The people in age group 18 to 30 are indeed placing more orders, and above 50 are placing less orders. Um, okay, this is good information. Can we quickly check if what is the value in currency, how much amount they are paying with respect to these age groups? So again, I go to data, selected the data set, insert, pivot table, and create a new. Again, my rows remain age, but this time I want to see as values order, average order value, and not the sum, because more people, more order. I want to check the average. Um and look at what is this telling us. This is telling us that people in the age group, so our intuition was a bit right, that although the people in the age group above 50, they are placing less orders, and people in the age group 18 to 30 are placing more orders, but the people above 50 are placing orders of higher value compared to the people in the age group 18 to 30. So above 50 people are placing an order of average 900, compared to 18 to 30, who are placing an average order of value 714. This might be interesting for our marketing team. But I want to check one last thing. Can we actually see that what is the number of average value when I divide it based on the number of orders that they are placing? So let me add one more pivot table. Again, I go back to my data, selected the data, I go to insert, I go to pivot table, I create a new pivot table, and then I say, okay, I want to see all the people of different age groups. And now I want to see how much orders they are placing. So add a number of orders in a month, but not as a value, rather columns. So number of orders in a month became my columns. And now here I want to see their values as average order value, and not their sum, rather I want to see the average. So now here we have a more detailed insight into, okay, people who were in the age group 18 to 30, when they were placing only one order, they were placing that of a low value. But when they were placing those in like number of orders increased for 6 or 7 times, their average spending actually increased. Is this telling us anything else? The purpose of all this is, you need to know what question to ask, because as you ask yourself questions, you can actually find those answers, and you can make them as varied as you want, and you can make them as detailed as you want. And finally, now that you have the data that you like, you have information that you would like to share, so now you can go to your final step, which is the data visualization and storytelling, and you can create for each of these questions the most appropriate visualization. And quickly, let's see how does that look like. So for example, again, the nice thing about these tools is that they suggest you what do you want to create, and we can insert charts here. So I selected the data. For example, I made sure that I'm not selecting the grand total here, I'm just selecting the data points, and I go to insert, and I insert a chart. And here, Google suggested that you insert a pie chart. You can also insert a different kind of chart here if you want, if it makes sense. But here, this chart clearly shows us that yes, 18 to 30 is the biggest age group. It's actually 68.5% of our total customer base who is placing orders. Let's see if we find something else, if we want to represent something else here. Let's say we want to differentiate between, we want to represent this spending. We select the data, we go to insert chart, and here we get a clear-cut comparison, and this is a bar chart. And again, it's a column chart where Google is telling us which kind of chart you want. On the right side, you can see, no, I don't want a column chart. Maybe I want to see something else. And for some other kind of data point, something else might make more sense. And you can pick the type of chart that you want to have. But here, a comparison in terms of um, uh, comparative analysis of which data set has more values makes more sense. And you can imagine just looking at this chart gives you a much more clearer indication that above 50 is the highest one, and then we have 30 to 40, and then these groups, and it's much more easy to see, easy to read than just having a look at these individual table and data points. And for example, here, how do we want to represent this information? So maybe we pick this data, select the data, go to insert, select the chart, and does this make sense that for number one order, this was the different distribution? Yeah, it looks complicated, impressive if you don't may want to explain anything to anyone, but this is not telling us anything. Maybe we can try to have a line chart here, and yeah, this makes much more sense. This is how we can compare that this orange line actually is telling us which age group are we talking about. This is above average most of the time, and especially when the number of orders increase to 9, 10, these people are spending a lot, and this is the age group 30 to 40. And here 18 to 13, where is my 18 to 13? This is this one. And yeah, they are placing a lot of orders, but they are really on the lower side. And this might be the story that you would like to tell. And this actually brings us to the end of our pipeline. What's left is only how you want to create this and present this in a compelling way. How are you going to phrase these visualizations in a way so that it allows your marketing team to actually make the decision that, okay, this is the age group that you want to or they want to target. And for this, Google actually also provides us with one more tool, which is the Google Slides. You can go to the apps, you can create slides, and you can copy these. You can create a blank slide, and you can like our target customers, and then you can yeah, you can just add slides, and then you can copy these plots, and you can actually paste them here, and you can also give all these recommendations that, and you can tell story that, hey, you may think that 18 to 30 is the right age group, but we recommend that it's actually 30 to 40 that you should target because they spend more. And you can show this by having some nice visualizations and presentation. And with this, I come to an end to my quick introduction to the pipeline. What you just saw is from end to end, how does a data analysis pipeline look like, how you start collecting the data, how you clean it up, how you get initial insights, how you do more detailed analysis, how you actually present those findings using visualization. And thank you very much for your patience. Now I invite Laura back on stage, and I'm looking forward to have any questions from your side.
Thank you so much, Dr. Humera. Now
Thank you.
we'll be taking a few questions from the audience. Before we do that, I just want to remind everyone that this September we're offering Women in Tech scholarships worth up to 18.5% off our main career change programs. You can click the sticky note in the top right corner of Big Marker to find out more. And I think the questions are more on the technical side because it's a workshop. So we'll see which ones we can get answered. So the first question is, in the pivot chart, can they use the world map?
Yes. So not in the pivot table as in the table, but when you are inserting the chart, you can definitely do that. And for this, the table has to have some geolocation related parameters like country names or continent names. In our data, we didn't have that. We didn't need that, or we couldn't use that. But if your data has country specific information, then you can use geocharts as part of your visualization.
Cool. The next question is, because I think the data set opened up as an Excel sheet. So some of the students were wondering if they can use Microsoft Excel to do this instead of Google Spreadsheets when they rewatch the webinar.
Definitely, definitely. As I said in the beginning, if you have Excel, you can do it. The process remains exactly the same.
Great. And just as a reminder to everyone, if you signed up for the event via Big Marker, which you most likely did because you're here, you'll be getting a recording via email a couple days after the webinar. And you can also go check out our LinkedIn because we are streaming the event there, and it'll be live as well for you to rewatch and do the webinar, do the workshop again. A slightly more technical question from a student is how can they delete duplicate data once they're in the spreadsheet?
I'll quickly show it to you again. You see my screen. You have the data. You select the data. It's always important that you select the data. You go to data. You go to data cleanup, and then you have remove duplicates. And when you click that, you pick up which columns do you want to see for analyzing, and you pick all of them maybe, and then if the data has a header row or not, and then you select remove duplicates. We don't have any duplicates at the moment because we deleted them in the beginning, but this is how you do it.
Thank you very much. And we're starting to get more questions. So I'll try to take care of the more technical ones first, and then we'll go to the career focused ones. So maybe you'll have to share your screen again, because one question is if you could please repeat how to draw the average.
How I draw the average. So let's quickly go to the screen back again. I come here, and this time I'll take this opportunity. I come here, and let me check not the number of orders, rather let's try to find the average of order value. And order value is the variable that we want to check. For any formula, you start by typing equal to, not question mark, equal to, and then you type what do you want to calculate. Since we want to calculate average, you say average, A-V-E-R-A. You can type it full or you can hit enter and it goes into autocomplete. Then you start the bracket and then you go to pick the data. Where is our data? It's in the data sheet. And which column is it? It's this one, or average order value. So I pick that, and you see that it shows E here. And now I can close this bracket and hit enter. And then it says, okay, order average value is 747. And same goes for every other formula.
Great. Another technical question is whether students should just download the data and open it, or should they open a blank sheet and import?
If you want to just open it, you can open it as it is. Because this is Excel, it will open it as a spreadsheet automatically. There are other formats of data as well. For example, CSV, which is comma separated value, or TSV, tab separated value. And in that case, just opening it won't help. You'll have to open a blank sheet and then import the data. By default, try to open it. If it opens as this nice tabular form, continue working on it. And if you see that no, it opened in a messed up format, then open a sheet first and then import the data.
Great. Another question we have is, now we're shifting to questions about career. So what advice would you give to people who want to change careers into data analytics?
Do it. Okay, on a more serious note. So when you are changing career, it could be a bit overwhelming because you don't know where to get started with. Identify where you want to get. So first of all, identify which field you want to go to. Let's say data analytics, and identify the technical skills that you would need and the soft skills that you would need. A course like this one, and I'm sure Laura, you'll tell more about subsequent courses that they can join, are a very good starting place. So, for example, from CareerFoundry last year, we did a short course series, a 5-course series, which was a bit longer version of what we did today, where you could see how you could apply these steps in more detail. And such a short course would be a good starting point. And even a longer course with a few months under your belt would be a very good starting point. So look at these courses, and if you don't want to join any course, at least identify what skills are needed, and in terms of tech and in terms of soft skills that you would have to work on.
And in regards to skills specifically, do you think coding skills are needed for data analysts?
That's a very good question. To get started, no, you don't need to. So you are very well off when you start with what we learned today. So a little bit of hands-on experience in processing a spreadsheet. But did you notice when we had to replace the food order value, we had to manually go and find, replace everything several times? If we would have known coding a little bit, we could have written a little script that would read all the data and do that replacement. And right now we did a little bit of statistical information like maximum, minimum, average. You may want to get more in-depth information, or your data set might be bigger. So as you will grow into more complicated data sets and more complicated problems, coding will become more handy. It will make your task easy. But I've seen many data analysts who focus only on Excel. And Excel in itself is a very powerful tool. And without using any coding, I've seen data analysts actually provide services. So, short answer, no, you don't need coding to get started. Longer answer, as I just said, it will make your life easier if you and give you more confidence if you have a bit of coding knowledge.
Great answer. I think across all of our programs, learning how to code is always a plus, but not a must, especially
Exactly.
for UX designers. I think it's also good to know both, but it's not necessary.
Mhm.
Next
And now
question
that
is,
you mentioned, sorry, Laura, to cut you off, now that you mentioned, actually, the way this course has been arranged, I really love it because it starts in the first module with Excel only. Then in the second module, it goes to second, third module, it goes into visualization tools like Tableau, and then you move towards SQL and then Python as a programming language. So you really get a feel of what data analyst does in the first 3 months of your course without using any coding. And then you get a little bit of flavor of, okay, what coding would add on top of it. So I really like the way it's arranged because it gives you the idea.
yeah, and hopefully this webinar also gave you an idea of what it's like to be a data analyst.
Mhm.
Another question we get a lot is, can a data analyst transition and become a data scientist or vice versa?
Mm, yes. The basic difference between a data analyst and a data scientist is what are you doing with the data? So a data analyst is looking at the data and trying to uncover patterns. A scientist is looking at the data and try to find things which are not in the data itself, but we can somehow learn what the data is telling and predict future things. Weather forecast, for example. So if I give you data about last beginning of this year till yesterday, and I say, okay, analyze the data and tell me how was weather in different parts of the world, data analysts can do that. And if I say, now tell me how will the weather be tomorrow and next month, the data analyst skills will be a bit limited here, and we will need data science skills. For that, you would need a little bit more maths, you'll need a lot more coding, because those models will have to be calculated and implemented. So yes, the transition can be done if you start as an analyst and you say, okay, now I learn these tools, more programming, more maths, and I go into data science. You can do that. And also vice versa, if somebody who has programming knowledge and they say, I don't want to predict things, I want to just analyze what's happening right now, so can go towards analysis. So yes, they are, from data analysis to science, it's more of an uphill journey. From science to analysis, it's easier.
Great to hear. And if you want to learn more about what the day-to-day of a data analyst looks like, check out our YouTube channel because we have a lot of content there. Moving on to another great question is, how can we build logical thinking about the questions that we answer after cleaning up the data?
Very good question. This comes with experience. And if you have domain knowledge, that would be very helpful for you. And to begin with, I would just say read and check out what others are asking, because then you start building that intuition. And it, as I also said in the beginning, that it's or towards the end, that it's very much related to who you are talking to. So the marketing person would be talking from their point of view, and sales people would be talking from their point of view, and you will be then they will be asking questions, and you as a data analyst would be giving the answers. So this is where a business analyst is different from data analyst. So data analyst are not supposed to or not expected to ask or know all the questions. It's something that develops over time. Business analyst, on the other hand, is somebody who knows the business and knows what questions to ask. um, Again, coming back to the course, this is where you would also learn step by step how to ask these questions in a logical way, and how you can generate hypothesis and then verify if that is, your assumption is right or not. And then maybe you'll find out it's not the right track, and you come back and then you change your original thinking. So it comes with practice.
Thank you, Dr. Humera. We have a few students joining late, but if you join late, don't worry. I'll drop the LinkedIn link below so that you can watch the recording on LinkedIn, and you'll receive a recording via video. I want to be mindful of time, but we have, let's see, I'll ask 3 more questions. So first off, John says, thank you for a great session. And he says he wants to switch from desktop support to becoming a data analyst. Does he need any special degree or certifications or projects that will help him land a job?
To land a job, it's important that you have a data analyst portfolio, so that you can showcase that you know what you are talking about. So if certification is a fast track to switch, but if you don't want to take up any certification, you can definitely acquire those skills and showcase those skills yourself. There are a lot of ways, and many people these days are, and companies these days are going towards freelancing, and there you do not need any to show any certification beforehand. Experience matters, and if you can show that, okay, you are coming from desktop support, which means you have a very good idea of how systems work, and if you have a bit of idea of programming as well, then you can definitely take up such projects. Start with Kaggle, for example, and build your own projects and then take them in your portfolio.
Great. The second question is, what other visualization tools like Tableau and Power BI should students learn? Should they learn these tools to work as a data analyst? What's your take on it? And if so, will we be having another tutorial on Tableau skills?
You answered your question already. These are the most common tools, like Google Analytics tool is there, Power BI is there, Tableau is there. It's really a matter of personal favorites. I've worked with Tableau more, so I like Tableau. And companies actually do not care which tool you are talking about until and unless in very specific situations they say, no, we have been working on Power BI, so we want to stay with Power BI, and it doesn't matter if you know Tableau. This happens very rarely. So whenever you'll see job opportunities, you'll see them as one of the following, so // so you can pick up any of those. And for a Tableau tutorial, I'll let you answer, Laura, if that's part of the plan.
I think we'll have to talk about it, but definitely if you guys want, it looks promising and we should definitely launch a new tutorial. Why not?
Definitely. And I must say that the main course that has Tableau as part of it.
Yep. Maybe we'll launch a new tutorial next year. We'll see. And last question from Faith. How can students create a portfolio?
How can students create a portfolio? Think of yourself as you are presenting yourself, and the hiring manager, you want to impress the hiring manager. How would you do that? One is you will have to have some projects that you have worked on. And the second is those projects will most, as part of the pipeline, the final step would be some questions answered with some visuals. So when you create your portfolio, you pick up those projects and you try to showcase what were the questions, what are the answers, while highlighting your skills. So you want to showcase that, I know how line charts work. I know how pie chart works. What kind of questions do they answer, etc. And this is how you create a portfolio where you show your projects, you show your skills. And also, this course has a product portfolio or your portfolio as part of the program. So by the end of this course, you will be developing your own portfolio with all the 5-6 different projects that you have worked on. I can strongly recommend you to check out the different portfolios of data analysts online. In fact, let me quickly find out. There is a CareerFoundry blog on data analyst portfolios out there. So yeah, I can try to find it for you, or maybe you can search for it as well on data analyst portfolios. And there are very good examples of how does a portfolio look like.
That's correct. And with that, I want to be mindful of time. We've had some amazing questions, but we're coming to the end of the webinar. As Dr. Humera said, if you go onto your blog, we have a blog post called 9 of the best data analytics portfolios on the web. And there you can check out a few of those. I'll drop the link here below.
Yeah.
And just as a reminder, this September, we're offering Women in Tech scholarships up to 18.5% of our main career change programs. As we all know, women are still vastly underrepresented in crucial industries like tech, and we've also borne the brunt of the social and economic devastation caused by the pandemic. So we hope that our Women in Tech scholarship encourages even more women to pursue careers in tech and become leaders. To claim your scholarship, simply book a call with a program advisor. You can click the sticky note in the top right corner of big marker. Again, as I said, you can head over to our LinkedIn to check out the recording of the webinar. And once again, I really want to thank Dr. Humera and also let you know that we got a lot of thank yous on our chat for the amazing presentation and workshop. You've really helped our students. Again, the thank yous keep coming. So thank you so much for a great session.
Thank you very much.
Everyone. And stay tuned to our upcoming events on our online events page. And until next time.
Thank you so much. And till next time. Bye. So many thank yous. All right then, Laura. I'll catch you on email.
Okay.
Bye. Have a great evening.